In this video, we're going to continue with our discussion of a hello world in a pretty simple 8-bit architecture, sort of. So we're working at assembly level. And here's where we ended part A. We have our string hello world loaded up into memory. We can see it there starting at location 02. And then it ends with that 00 at the end of the line. After the exclamation point, we need the string termination character, and that's the 00. And then we have the beginning of our program, the start of our program, indicated there by the IP, the instruction pointer, pointing to that 06. That will be our first instruction. Okay. So when our program was loaded in, part of the program was labeled start. That got mapped to the memory location 0F. That was put into the instruction pointer. And the purpose of the instruction pointer is to tell us what we're executing. So we're getting ready to execute our first instruction, which was at the start of the program 0F. And there we are. And it didn't start at the beginning because of our data. For instance, the hello world took up some time. And if you look back and see the assembly, one thing you'll note is that anything after a semicolon in our assembly program was a comment. And so the things before that will have some correspondence to machine code and will be written as some hexadecimal digits, but everything after a semicolon is a comment and has no like machine code equivalent. Okay. So here we are at start, and it is labeled the instruction being that we're going to execute next is this move C hello. And so the instruction consists of some data and some action and some data, some opcode and operands. So the 06 we see there at the end of the first line is this instruction that we want to move some piece of data. And then it's telling us to move something into a register C. So the registers are A, B, C, D, and they're going to correspond to A is going to be 0, B is going to be 1, C is going to be 2. So we're going to move something into register C, which is labeled by the 2. And then what we're moving there is the address of the hello data, and that's at memory address 2. So we see there at the end of the line is the 06, and then the beginning of line 2 has 0202. And so that is move into the register within the register 2012, which is C, move in the address of the hello string. So that's what we're doing. We're moving A2 into register C so that it is effectively pointing to the beginning of our string. Okay, and then after we execute that move instruction, then we increment our instruction pointer, the I, and so that is now at 1, 2. So that is pointing to, that's that medium blue, and so the instruction pointer is now at 12, pointing to another 06, another move. So now here we are at we have executed the move D 232. Okay, so that is the next instruction. So so that was the 0603E8. So D, A is 0, B is 1, C is 2, D is 3. So the 06 means move. That's the action. 03 tells us which register. The register 03, which is register D, and we are moving into that E8. So now it says in the assembly code, which is in decimal 232, but in our simulator, it's showing us that result in hex, and 232 decimal is E8 in hex. So that's where the E8 comes from. And that marks the uh, the beginning of our um, memory mapped output. So if we put something in there, then it's also going to display as output for us. So remember, our stack pointer is at E7 and sort of works backwards, and our memory mapped starts at output starts at 48 and is going to move sort of forward. And so that's what we're doing. We're making E point to the part of memory that corresponds to the output. All right, so now we are printing. Now I'm going to start breaking the instructions down. They get a little bit more complicated. So I'm breaking them down into sort of before, the setup, and the after. So I have call, print is the next thing. So the 38 is going to be the call, and then the 18 is what I'm going to be calling. So I'm calling 18 because when my program was put into memory, and there was one part of it that corresponded to a label, this print, and then that print got corresponding to the address 18. So I am going to call 18. I'm going to move to my subroutine, my printing subroutine. So this is I haven't done it yet, but I'm going to do it. So I'm pointing to my instruction pointer. It's pointing to the 38, and then the data is 18. That's the label where I'm going to move to. When I move to a subroutine, this is not just a pure jump to another line of code, but when you go to a subroutine, you have to be able to get back. And so we have to do something in order to be able to come back when we're done with the subroutine, and that's where our stack's going to be coming in. So we are going to put the sort of the value that of the code that is after the call, which is the sort of address of that HLT, that halt instruction. We're going to put that onto the stack so that when the time comes, we know where to go back to when we're returning from the subroutine. Remember, again, the stack has this LIFO protocol, so you can only access the top of the stack, and we are going to put at this time the top of the stack the address of the halt instruction, so we can come back from our subroutine call. Okay, so we put the 17, which is our return instruction, the address of our HLT instruction. We put that on the top of the stack, and then we move our stack pointer so that it's pointing to the next available thing on the stack. So we put the 17 on the top of the stack, we move our stack pointer so it's pointing to the next available slot on the stack, and we move our instruction pointer to that label, which was 18. Okay. So these didn't all have to be so close together, 17 and 18. It just so happened in this program that was the case. All right. So now we've called our printing subroutine. So now we're ready to do this instruction called push A. So pushing has to do with the stack. It means we're going to put something on the stack. The subroutine call also put something on the stack. So we already did sort of, there was already a push sort of as part of our subroutine call. Now this is a simpler push. And we're going to, so the 32 indicates that we are pushing. That's the opcode. It's understood because of the way a stack works. Push corresponds to a stack, and the stack, the thing you're dealing with a stack, is the top. So we don't have to say where or anything like that, but we just have to say what. And so the 00 corresponds to register A. So whatever the value is in register A, we're going to put there. Now it's a little bit confusing because the 00 refers to register A, and then it's the value of what happens to be in A is also 00. But it really is referring to the register, not what's in the register. Okay, so we're going to put this value that was in register A down onto the stack. One is we're just running a demo program and we can do this, so we're demoing something. But also, this is a normal thing of subroutines that you are going to use your registers in the subroutine. You might have been doing something before your subroutine. That's not the case here, but you might have been doing something before you went to the subroutine, but the subroutine is going to use your registers. So you want to like store the value of your registers in case you need them when you come back. Okay, so that's why we are storing this value of the register A. We're not going to do it. Right now I'm talking about before the push, then after the push. Um, what do we see here? The blue, the medium blue, the instruction pointer, every time we execute an instruction, moves to the next instruction. So it moved to 1A. The stack pointer changed because we pushed something onto the stack. So we see that value that was in register A00 got loaded to the top of the stack, and the stack pointer is now pointing to the next available slot. So that is the result of pushing A. Now we are pushing B. Again, same deal here. 32 is the push. The 01 refers to register B. And we're going to put that on. And it's the same idea as with A. We are going to, we may have done other things or be doing things after this subroutine. And so we might want those values back. There was nothing interesting in those values in this case, but just to show the sort of what normally happens with a subroutine, we're going through the whole spiel. Okay, so similar. The only difference here is we're pushing a value, but it's register B instead of register A this time. So that was our setup before, and here is after. Again, increment this the IP, the instruction pointer. In this case, also change the stack pointer. In this case, we're decreasing the stack pointer because of the way the stack works in this architecture. And so we've taken the value of B and put it on the top of the stack. We're pointing to the next available slot in the stack. We're pointing to the next instruction with IP. All right. So now we've pushed A, we've pushed B in that print section. We're ready for the next instruction, the move. Okay. So now we are going to put move into register B A0. Okay. Now again, this looks a little bit confusing because it already had a 0 and now we're putting a 0, but there is a purpose here, and that is that 0 is our string termination character. And so as we're walking through the hello world string, we need to know when it's done. It's going to be done when we reach the 0. So you can see again in that first row, you see the 48, that's the capital H, and then the 21 was the exclamation point of hello world. And then that 00 following the 21, that's the string termination character. And we want to compare that to something, and we're going to compare it to what's in register B. And so we're putting a 0 in register B so we can compare eventually that value after the 21, 0 to what's in register B, the 0 to know that we're done the string. Okay, so that's what we're doing. So we're moving a 0 into register B. So we've done that. Um, so there was a 0 written into B, and our instruction pointer gets incremented again. Okay, so we've done that. Now it's after, and we've done that move. So now we're down at the bottom of the section labeled print, and we're ready to start the loop section. So I'm going to go through one iteration of loop and then end this section. All right, so now we are in the section of the code marked as loop.loop, and our first instruction is going to be move A, and we have the square bracket C. And this time, the opcode, the action, is for the move is 03, whereas before we were seeing a 06. There's more than one kind of move, as we will see. Are we moving? We have the action and we have the data, but you have to know how to interpret the data. There are different kinds of move. I might be moving an actual value into a register. I might be moving the value at an address into there. So there are addresses, there's actual data, there are the registers. I might be moving from one register to another register. So there are different versions of move. And so I'm going to move C. C is the one in the assembly with the square brackets around it. That's indicating that I want not the uh, value of C, but the value pointed to by C. So C has a 02. I'm going to go into my RAM. I'm going to find what's at location 2, which is a 48. And that's what I'm going to put into register A. And then, as always, increment the IP, the instruction pointer. So there's a lot of what happened. Okay, so I took my 2 registers. C had a 2. It was pointing at the 48. That 48 was moved into register A, and then the instruction pointer is now pointing at the next instruction, 5. Okay. So now we're ready for the next instruction. And this is so let me go to the next slide. This is move square bracket DA. Again, so the square bracket means like it's this we're dealing with memory and locations. So the C in the previous instruction was an address, and that goes also here for the D. Now this has a different opcode. It's another variation of move because it is, again, I'm working with an address, but I'm working with before I was taking something from memory to a register. Now I'm taking something from a register to a memory location and address. So the roles have been a little bit reversed. So I have yet another version of move. I am moving what's in A, which is now that 48, and I'm moving it to memory at a location indicated by register D, which has the E8. And so then I'm going to move the 8 into, move the 48 into location, uh, where was it again? E8. Okay, so I haven't done it yet. This is before it. Now I do it. So my IP in the medium blue, I've moved to the next instruction. But what have I just done? I have taken the 48 that was in the register and moved it to the 40 into location. I've taken the value of 48 and I've moved it into the memory location E8, which is my first memory mapped location. And so you see up there in the gray output near the top, the capital H, which corresponds to the 48. Okay, so I've displayed my first letter. I want to move on to my next letter and put it into the next memory mapped location. So C is where in memory is my string I want to display. So I have to increment C. Right now it has a 2 and it's pointing to the capital H. I want to move it to where I'm pointing to the little e, the next letter in the next character in hello world. So that is this increment C. And now it's a 3 and I'm pointing to the 65, the little e, and I've changed my uh, instruction pointer. Okay, my next instruction is increment D. D was pointing to the first memory map location, and I don't want to overwrite my H. I want to go move to the next memory map location, so I'm going to increment D. And so now I am now pointing, I went from E8 to E9 in register D. I'm pointing to, I'm going to use that to point to the second memory map location. And I've, as always, I have changed my instruction pointer to move to the next thing. All right. So now my next instruction on before my next instruction, breaking it down in detail, sort of before and after, I have a compare. 15 was a compare. I'm going to compare B and C. This is a particular version of compare. So there may be other compares, like there were other moves, but this compare is comparing what's in register B to what's pointed to by register C. So what's pointed to by register C is the 65, the little e. And I'm comparing that to what's in B, which is a 0. And I'm asking the question, am I at the string terminating character, which is 0? And so I'm doing a comparison, and the answer will be false. They are not the same. So that's the reason I'm making the comparison. I'm going to make the comparison, and I will update if necessary. So I'm going to write the result into Z. Z already says false, and I'm going to, when I do this comparison, I'm going to get another false. So I'm going to write a false over a false. So you won't see a change, but I did do something. This emulator did do something. It wrote false to that flag Z. Okay, so we compared the B to the 65. Were they the same? No, they're not. We wrote a false to Z, and then we moved to the next instruction. So we're down near the bottom of the loop section. We just did the compare, and now we're going to do the jump with sort of a jump if not. So that's what the comment is calling it, the jump if not. And so we're going to look at Z and decide whether to jump. And if it's so the Z is false. And so if it's not the false, so the opposite not of the false is true, so we are going to jump. And so we are jumping to 1F. But based on this condition. So we look at Z. Z is false, so we are indeed jumping. We're jumping to the part of the code labeled dot loop, which was that 1F. So that dot loop in our assembly got mapped on to 1F when we went to machine code, and we are jumping, and we're sort of jumping back. So that's giving us our looping structure. So we were not at the end of the string. 65 is not the string termination character. The flag Z got a false. If the flag is not true, we are jumping. It was false, so we are jumping. We're jumping back, and so we are getting ready to go back to the move instruction. So we've completed our first iteration, and we're back at the top of the loop. So I'm going to stop here